So another fun problem to do by trig substitution is whenever we have radicals and they're in the numerator of a function. We're going to try it here and hope that it works out well for us. So we're going to try to evaluate the integral of the square root of x squared plus 1. And whenever we see this, the trig identity is going to be that x is equal to tangent of theta. Right, then dx is equal to secant squared theta d theta. Right, now we make the substitution here. We get the square root of tangent squared theta plus 1, and then secant squared theta d theta. Right, and then this one is going to come out to a secant theta like we saw in the previous video. Right, we get secant theta times a secant squared theta d theta. So now we're actually going to have the secant cubed function, which is a little bit harder to integrate, and we actually had a lab about this. But if you remember, the method there was to do the integration by parts. So u is equal to secant theta, du is equal to secant theta tan theta. Right, then our dv is equal to secant squared theta, and our v is equal to tangent of theta. Right, and so then we get that the integral of secant cubed theta is equal to our u secant theta, or v tangent theta, minus the integral of our du and our v, so tangent theta secant theta tan theta, right? So we have a tangent squared theta is equal to secant theta tangent theta minus tangent squared theta secant theta. Now it's kind of difficult to see where we ought to go from here, but if we use our trig identity, we get minus the integral of secant squared theta minus 1 secant theta d theta. Right, and so then we get that the integral of secant cubed theta is equal to secant theta tangent of theta minus the integral of, right, if we distribute our secant theta, secant cubed theta minus secant theta. Now, this can also be an integral, right, if we distribute the integral along with the secant. And so here we got to notice that we have these secant cubes. We're going to use this slingshot method, right? We're going to bring it all the way back. We're going to get that 2 times the integral of secant cubed of theta is equal to secant theta tangent of theta minus, right, the integral of secant theta. Right, and here the integral of secant theta is something that we know. It is the integral of secant theta is the ln tangent theta plus secant theta. Right. But remember, we have that this is the evaluation for 2 times that integral, so we divide by a half, and we get that the integral of secant cubed of theta is equal to 1/2 secant theta tangent of theta minus ln tangent of theta plus secant theta. Right, and here we have to do our little triangle to see what we ought to plug into our thetas here. Right, so our theta was an arctangent x over 1, x over 1, and then our hypotenuse here is going to be x squared plus 1, right? So our tangent of this arctangent is actually just going to be, right, it's just going to be x, right? So wherever we see the tangent, we'll be able to plug it in x. But our secant is going to be, again, this was the same triangle we had in the last video. It's going to be 1 over cosine, so it's going to be 1 over adjacent over hypotenuse. So it's going to be a hypotenuse over adjacent, right? So we're going to get equal to 1/2, right? Our hypotenuse is x squared plus 1. our tangent theta is equal to x minus ln, right, x plus square root x squared plus 1 plus our constant. And that's the final answer for the square root of x squared plus 1.